So, introduction about pulping and bleaching technology. Introduction to pulping technology. Pulping is the fundamental and primary stage in the manufacturing of paper and paperboard products. It involves the disintegration of lignocellulosic material typically derived from plant sources into a fibrous mass suitable for paper making. The core aim of pulping is to separate the cellulose fibers present in the raw material from other non-cellulosic components, especially lignin, which acts as a binder holding the fibers together in their natural structure. The process of pulping is not just mechanical or chemical, it is a combination of physical disintegration, chemical treatment, and energy intensive operations, each aimed at liberating usable fibers in the most efficient and environmentally sustainable manner possible. The importance of pulping in the paper industry cannot be overstated. It directly affects the quality of final paper product, its brightness, strength, porosity, absorbency, and surface finish. The choice of pulping method, that is mechanical, chemical, or semi-chemical, influences the properties of the paper, production cost, and environmental footprint. In the age of sustainability and increasing environmental awareness, pulping also represents a vital area of innovation, with new developments focusing on cleaner processes, use of non-wood raw materials, energy efficiency, and maximum resource utilization. The objectives of pulping are multifaceted. First and foremost, pulping aims to disintegrate the raw plant materials into its components fibers while retaining their integrity as much as possible. This disintegration allows these fibers to later be suspended in water to form a slurry known as stock or varnish, which is then processed further into paper making. Some of the primary objectives of pulping includes liberation of fibers, separate the individual cellulose fibers from each other by breaking the bonds created by lignin and hemicellulose, prevention of fiber structure, retain the strength of cellulosic fibers during the pulping process to ensure a strong final paper product, removal of non-cellulosic components, remove lignin, extractives, and inorganic materials like ash, which can interfere with the paper making process and the quality of paper. Improvement of bleachability. Prepare the pulp for bleaching operations by reducing lignin contents. Maximization of yield. Achieve the highest possible yield of usable fibers from raw materials while balancing economic and environmental cost. Environmental considerations. Minimize the generation of pollutants and manage energy and water use effectively. Raw material used for pulping. Pulping can utilize a diverse array of raw materials depending on availability, cost, and desired paper properties. Broadly, raw materials are classified into two categories. First is wood based and second one is non-wood-based raw materials. Wood-based raw materials. Wood is the most commonly used raw material for pulping and is primarily categorized into softwoods and hardwoods. In softwoods, the examples are pine, spruce, and fir, characterized by long cellulosic fibers 3 to 4 mm in length, which provides excellent tensile strength and bulk to the paper. Softwoods are ideal for products requiring strength such as packaging paper and cardboard. Hardwoods, example eucalyptus, birch, poplar, possesses shorter fibers 0.7 to 1.5 mm, leading to better formation, smooth surface, and printability in the final paper, commonly used in writing, printing, and tissue papers. Non-wood raw materials. Due to limited forest resources and increasing demand for paper, non-wood raw materials are gaining significant, especially in developing countries. Agriculture residues, wheat straw, rice straw, corn straw, and sugarcane bagasse are widely used due to their availability and low cost. Annual plants. This is also the source of paper making fiber. That is, the plants like canaf, hemp, flax have excellent fiber content and are cultivated specifically for pulping in some regions. Grasses and reeds, bamboo, elephant grass, and Swiss grass are promising due to fast growth and high biomass yield. Fiber composition of raw materials, composition and their approximate percentage. So the cellulose is 40 to 50%, hemicellulose is 20 to 35%, lignin 15 to 30%, extractive 1 to 5%, as 0.5 to 3%. Next is classification of pulping processes. Pulping processes are generally classified based on the method used to separate fibers. First one is the mechanical pulping. So mechanical pulping uses physical force to separate fibers with minimal chemical involvement. It has high yield up to 95% but low paper strength. Next one is the chemical process. Involves chemicals to dissolve lignin and separate fibers, produces stronger pulp with lower yield. Next one is semi-chemical pulping. Combines mild chemical treatment with mechanical refining, used for medium strength paper and board. Importance of pulping. Pulping determines fiber properties, influences paper making efficiency, and affects final product quality. It is also a key factor in environment sustainability of paper industry. Definition of important terms. First one is the pulp. So pulp is the fibrous cellulosic material obtained by separating fibers from lignocellulosic raw materials like wood, straw, bagasse, or grasses. It serves as the primary raw material for the manufacturing of paper and paperboard. The process of pulping involves either mechanical grinding or chemical disintegration to break down the plant structure and release individual fibers. There are different types of pulp: mechanical, chemical, and recycled, each with specific properties and end-use applications. The characteristics of pulp, including fiber length, brightness, lignin content, and strength, determine the sustainability for various grades of paper. Pulp can be bleached or unbleached depending on the application. The quality of pulp depends on raw material type, pulping method, and process control during manufacturing. Pulp is often dried into sheets for transportation, market pulp, or used directly on site in integrated mills. It is a critical commodity in the global paper supply chain. Next is the definition of paper. So what is paper? Paper is a thin, flat and flexible material primarily composed of cellulose fibers derived from plant sources such as wood, agriculture residue or recycled paper. In technical terms, paper is defined as a felted or bonded sheet formed of fibers, commonly cellulose, which has been deposited from a water suspension onto a screen or wire mesh, drained and dried to produce a continuous web with uniform properties. So this is the technical definition of this paper. Composition of paper. Technically, the primary components of paper is cellulose, which is the most abundant organic polymer on earth. It is a long chain polysaccharide composed of beta 1:4 linked D-glucose units. In addition to cellulose, paper may contain hemicellulose, act as a filler and contribute to bonding. Lignin removed during pulping. Residual lignin reduces brightness and paper permeance. Additives, fillers, sizing agents and strengthening agents are added to enhance paper performance. Water present during the paper making process but mostly removed before final drying. Manufacturing process overview. Technically, paper is manufactured in the following steps. Number one is pulping. Conversion of raw plant material into fibers through mechanical, chemical or semi-chemical methods. Screening and cleaning. Removal of impurities and overside particles. Refining. Mechanical treatment of pulp to improve fiber bonding. Sheet formation. Dispersion of fiber in water. Deposition on a moving screen wire. And formation of a wet web. Pressing. Removal of water by mechanical pressure. Drying. Thermal drying using steam heated cylinders or dryers. Finishing. Calendering, coating or cutting into sheets or rolls. Fundamental characteristics. Technical paper properties are defined by first one is the grammage, gram per meter square, mass per unit area, caliper, thickness of sheet, bursting strength, tensile strength, tear resistance, folding endurance, etc. Porosity, air permeability, important in printing and packaging. Opacity and brightness, asynthetics and readability factors. Moisture content, critical for dimensional stability. Fiber sources. Paper can be made from various raw materials: wood, softwood and hardwood. Main commercial sources typically 40 to 50% cellulose, agriculture residues, wheat straw, bagasse, rice, husk, kernel, recycled fibers from old paper, packaging and newsprints. Types of papers. Based on applications and properties, technical classification includes writing and printing paper, high brightness, good surface finish is the property. packaging paper, craft paper and high strength papers. Tissue papers, soft and lightweight. Special means specialty papers, filter paper, photography paper and thermal paper, etc. Importance in industry. Paper serves in education, books, notebooks and printing, communication, newspapers, forms, packaging, labels, etc. Hygienic, tissues, napkin papers, industrial, insulation papers and filtering medias. Lignin is a complex phenolic polymer found in the secondary cell walls of plants. It acts as a binder that provides structural integrity and rigidity to the plant. Lignin fills the space between cellulose, hemicellulose and pectin components, effectively gluing the fiber together. In the context of pulping, lignin is considered as undesirable component that must be removed to free the cellulose fibers. Its removal is essential for producing high quality paper. The chemical pulping process, particularly the craft process, is designed to dissolve the removed lignin without significantly damaging the cellulose fibers. Lignin is also a source of valuable chemicals and energy. It is burned in the recovery boilers to generate stems and electricity in craft mills. Moderate research is exploring lignin valorization pathways such as bio-based resins, carbon fibers, and vanillin production. Delignification. Delignification is the process of removing lignin from lignocellulosic materials. It is the core step in chemical pulping and bleaching. Effective delignification is critical to achieve high pulp purity, brightness and strength. There are multiple delignification stages: initial chemical cooking, extended delignification and bleaching. Different chemicals are used depending on the pulping processes. For instance, the craft process use sodium hydroxide and sodium sulfite. Sulfite pulping uses sulfurous acid. Enzymatic and oxidative delignification methods are emerging as sustainable alternatives. Incomplete delignification affects pulp bleachability and paper quality. Over delignification can damage cellulose and reduce yield. Hence, careful control is necessary. The efficiency of delignification is measured using kappa number, which indicates residual lignin content in the pulp. Yield. In pulping, yield refers to the proportion of dry pulp obtained from dry raw material, expressed as a percentage. For example, if 1000 kg of dry wood yields 500 kg of dry pulp, the yield is 50%. Yield is a key performance indicator in pulp production. Mechanical pulping offers high yield, 90 to 95%. Since most of the raw material is retained, however, the quality of such pulp is lower due to high lignin content. Chemical pulping has lower yield, 40 to 55%, but results in stronger, more durable paper. Yield is influenced by raw material type, pulping method and process conditions. Maximizing yield while maintaining pulp quality and environmental compliance is a major challenge for pulp mills. Yield directly impacts profitability, energy uses and environmental footprints. Bleaching. Bleaching is the chemical treatment of pulp to improve its brightness and remove residual lignin and color bodies. It is especially important for producing high grade white paper. The bleaching sequence varies based on the type of pulp. For chemical pulp, multiple stages like oxygen delignification, chlorine dioxide treatment, hydrogen peroxide application, and alkaline extraction are used. Elemental chlorine-free and totally chlorine-free processes are adopted to reduce environmental impact. Bleaching must be carefully controlled to avoid damaging cellulose fibers, which can reduce paper strength. The brightness of bleached pulp is measured using standardized methods and expressed as a percentage of reflectance. In addition to brightness, pulping improves pulp cleanliness, reduces ink absorption, and enhances printing quality. Environmental aspects such as AOX are closely monitored during bleaching operations.